All right, ladies and gentlemen of Algebra 2, you are looking at the end of Unit 3. This is the last piece of this, and this is kind of putting everything together that you've been working on so far, especially the last piece with graphing inequality. So this is called linear programming, and what it does is basically it takes your graphing and kind of takes it to the next level. So you're looking at what is the best situation that can come about for a given scenario. So kind of what you're looking at. Linear programming calls for optimization, all right? And kind of what that is that you're trying to do things either minimize or maximize things like maximize profits or minimize cost or things like that. There's a lot of applications to business here. So what you're doing is basically this. Graphing the system of constraints over here, like these would be my constraints. Then you're going to find the vertices, so you're going to figure out where your corners are, where it hits. And then the inside part, the shaded part, is called a feasible region. All right, and then you evaluate the objective quantity at each vertex. So the minimum and the maximum is the highest, is the lowest and the highest respectively. So what you're doing is, for a given function, for a given objective function, you're trying to figure out what is the best case scenario here. So let's kind of talking about. So for this problem, here's your objective function. We're trying to find the maximum and the minimum value. So if you're looking, here's your function, and here's your constraints, and here is kind of what you're trying to figure out. So you just want to kind of do what we were doing before. So graph these things and then see what we got. So let's take a look. So if I zoom in here a little bit, so x greater than or equal to 1, so that'll be a solid line right at 1, and that's going to go bigger. So then y greater than 0, so that's right there, and that's going to go up. So, and then here's kind of my wild card, so I got to do a little bit of algebra here, 2x plus 6. So if I'm up at 6, I'm going to go down 2 over 1, down 2 over 1. And if I'm very picky about my points, I can kind of start to see which way I'm going. So test 0, 0, like always, is 0 less than or equal to 6. That's true. So my feasible region here is going to be just this little piece right here. Right here. This is going to be my feasible region, just this little part. So now what I want to do is look at where do I cross. Well, I cross right here, and that's going to be at 1, 0. I cross right here, that's going to be at 3, 0. And I also cross right here, which is going to be at 1, 4. So my points then are going to be, that's going to be the vertices of my feasible region. So when I go to check, here's what I want to do. So take 3x plus y. I want to put each point in there and see what I get. All right, so 1, 0, that'll be 3 times 1 plus 0 equals 3. 3, 0, 3 times 3 plus 0 equals 9. And my last one's going to be 1, 4. So that'll be 3 times 1 plus 4 equals 7. So once I do that, I can look and see what's my minimum, what's my maximum. Well, this one's my minimum, this one's my maximum. That's all I'm asking for. Which one's a minimum, which one's a maximum? Most of the time they'll ask you for one or the other. They won't ask you for both. So, but just bear in mind for this problem, they're looking for both, so I gave them both. So, same kind of idea here, minimum, maximum values for this function. So again, I want to graph all of these things. So let's go purple here for x less than or equal to 2. So that's going to be right here. I'm going this way. If I go here, I'll do the bottom one. Y greater than or equal to x minus 2. So that's there, 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 there. So I can start to kind of look at this. So 0 then, 0 minus 2. Is 0 greater than or equal to negative 2? That's true. So I'm going to shade that way. So now here's kind of my wild card, so I got to play around with this a little bit. So 3x minus y greater than or equal to negative 2, negative y greater than or equal to negative 3x minus 2. So now if I switch all the signs, if I get rid of this negative, I got to switch all the signs, including that. So instead of going greater than, I got to switch to less than or equal to 3x plus 2. So if I do that, all right, so 3x plus 2, so I'm going to go up 3 over 1, and we're going to go back like so. And there's going to be my line right there. And I'm guessing I'm going to go back down towards this. So when I do that, it's going to look like this. So when I shade this, it's going to look like this. There's my shaded region. So now I need to look at the points and figure out what I'm dealing with. Let's just go black here. So this is going to be at 2, 0. So that's one of the points. This is at negative 2, negative 4. And this one up here, and you know, if I was a little bit better with the lines, that's going to cross right there. That's going to be at 2, 7. So there's my points. So you can see how it becomes pretty important to be picky about what your lines look like. It's not always very easy on the iPad, I'm not going to lie. So take a look. 2 times 2 minus 3 times 0 is going to equal 4. Okay, that's this point. Second point, that's going to be 2 times negative 2 minus 3 times negative 4. That's going to be, let's see, negative 4 plus 12, so that's going to be positive 8. And then 2, 7 is going to be here, so 2 times 2 minus 3 times 7. So that would be 4 minus 21. That will be negative 17. So this one ends up being the max. Okay, my second point, negative 2, negative 4. And then my minimum actually ends up being 2, 7. Okay, so there you go. That's what I'm looking for. So it's a whole process. It takes a little bit of time, takes a little bit of thought. But if you take one piece at a time, you can do it. If you it works a lot easier. So what you're trying to do is this. Define the variables, write a system of inequalities, graph that system, find the feasible region, the coordinates, write a linear function to be maximized or minimized, and then check it like we were doing, and then select the greatest or least result to answer the problem. So this is kind of, it takes a little bit of work, but it takes a little bit of process, but you can do it. So now what I'm going to look at is this. Look at this problem. A receptionist for a veterinarian, one of Dolores Alvarez's tasks is to schedule appointments. She allots 20 minutes for a routine office visit, 40 minutes for surgery. The veterinarian cannot do more than 6 surgeries per day. The office has 7 hours available for appointments. An office visit costs $55 and surgeries cost $125. How can she maximize the income for the day? So here's kind of what we're talking about. We're talking about two things, office visits and surgery. So define the variables. So let's let X be the office visits, and Y is going to be surgery. All right, now we're going to start looking at the system of inequality. So here's kind of my system of inequalities. You've only got 7 hours available for appointments per day. Okay, 7 hours times 60, that's 420 minutes. So 20x plus 40y has got to be less than or equal to 420. And I got this by taking 7 times 60 because there's 60 minutes in an hour. All right, now what I want to do next is this. The vet cannot do more than 6 surgeries per day. So that means y has got to be less than or equal to 6. The office has 7 hours available for appointments. Boom, there we go. So let's graph the system of equalities. But before I do that, I want to take a look here. A couple of things that I am hoping are kind of obvious. Obviously, you can't have negative office visits. Obviously, you can't have negative surgeries. So you got to be bigger than 0 on both of those. And then one thing I want to do before I get going, I'm looking at this equation and I'm thinking that is pretty big and probably tough to graph. I want to simplify it. So I want to simplify it by taking everything divided by 20. So I want to take this divided by 20, this divided by 20, this divided by 20. So this becomes x plus 2y all of a sudden is less than or equal to 21. This looks a lot easier to graph than this one. So so now this is a lot easier to handle. So if I was going to do a little bit more algebra, I can solve for y. So that'll be 2y less than or equal to negative x plus 21. Y less than or equal to negative 1/2 x plus 10.5 or 10.5. That I can graph. This I can definitely graph. Now I'm starting to kind of get an idea what this is going to look like. So if I look here, y's got to be less than or equal to 6. That's this one. So that's right here. And that's going to go down. Second one, y less than negative 1/2 x plus 10.5. So I'm going to go back up here. 10.5 is right about here. Okay, then I'm going to go down 1 over 2, like that. I'm going to be very picky about my line. So it's going to go like that. So feasible region. So you know, I can test out this point, but I'm hoping it's moderately obvious that 0 less than negative 1/2 times 0 plus 10.5. 0 less than or equal to 10.5. Absolutely, that's true. Checks out. So that means on the graph, it's going to be right in here. So here's my kind of next part to this. Coordinates of the feasible region. Well, take a look. You got 0, 0. Oops. Erase that. Let's small this up. So you got 0, 0 again. This is going to be 0, 6. This is going to be 5, 10, 15, 20. This is going to be 21, 0. And then this is going to be, let's see, 9, 6. 9, 6. So those are my points, 0, 6, 0, 0, 9, 6, 21, 0. So now those are my coordinates. Now it's time to look at my function. So the one thing I haven't really talked about at all in this entire problem is the costs. Office visits are 55, surgeries are 125, and I'm trying to maximize the income. Okay, so I'm looking at 55x plus 125y. And that's what I'm trying to maximize. I'm trying to make the most money I can throughout the day. So let's start plugging in these points and seeing what I get. So I can already probably eliminate 0, 0 because that means I haven't done anything all day. So that's probably not going to work. 21, 0, and 9, 6, and even 0, 6 I can try. Although 0, 6 is going to be eliminated because 9, 6, and 21, 0. 9 and 6 is obviously going to be bigger than 0, 6. So 55 times 9 plus 125 times 6. Or it's going to be 55 times 21 plus 125 times 0. So 9 times 55 plus 125 times 6, that's going to equal $1,245. 55 times 21 is going to equal $1,155. So my maximum is going to be 9 and 6. So in order to maximize the day, I'm going to want 9 office visits and 6 surgeries. All right, there's a lot of pieces to this. This takes time. You got to think things through. Come talk to me with questions. I can help you out. Have a good day.